All right. So, to recap, yesterday we were struggling because we imported our rendering library, OpenGL rendering library, and he calls, he uses OpenGL 4.6 features. DSA OpenGL is like the big ones, I think. Direct state access. All right, so these came in, I think, in like 4.6 or 4.5, right? So newer OpenGL, and these are functions that like didn't exist in original OpenGL. So we use these things, and we defined in our header somewhere typically. Let's see. We used to just define GLX prototypes and import GL. Then all of these functions that didn't used to be there are now defined, and we link against them, and everything's good, right? It turns out that the reason that we could just link against our GL library and see those functions is because we were using this thing called libglvnd, the GL vendor neutral dispatch library. And it turns out that this guy sits between us and like our actual OpenGL, right? So like this guy makes it so that I'm not really sure exactly of his purpose, but it's something to do with finding the correct OpenGL for your system. Like maybe you have both AMD and NVIDIA drivers installed in your system because you have two cards plugged in, or like you're integrated as AMD and you're like actual is NVIDIA. I think this makes it so that you can have both of those installed at the same time without conflict. It's like something like that. And it turns out that this guy is defining all of those functions for us. Our Alpine installation in our virtual machine that we're using for testing because, I can't test a window manager on my desktop and stream at the same time. That's just kind of hard without dual PC setup. It doesn't do this. And so all of these functions that we were like expecting to exist don't exist because they weren't in the original OpenGL, but you can get them if you dynamically load them. So a lot of people use this thing called GLAD, OpenGL, the OpenGL loader. And so we like pull this guy in, we try to use him, we kind of hacked up a bunch of stuff to make this work, to use this instead. But basically what happens is this guy defines a bunch of functions internally that will like load things dynamically if they have to exist. So if we look in like maybe like glad.c probably. Did I delete it already? No. Like if we look in here, we might see functions right, like this, right? He might say like, hey, actually this is the loading functions, which isn't really what I want. Maybe it's in the header file. Include glad glh. Can we look for like some here? So we might see something like this, right? Where he defines a function that you might have that you might have but might not have, and he like basically aliases himself to this, right? And if we look for this guy in here somewhere, we'll see that this is like some static constant that is null by default, right? And on load, he will like assign this thing with dynamic lookup, which is great. So we kind of pulled this guy in, but it didn't quite do what we wanted. Specifically, we're using an API which is supported in our OpenGL profile. If you look at this guy, EGL info, and we look for this function that is defined in this extension, GLOES EGL image. You'll see the word OES in here, which makes it sound like it's for OpenGL embedded, which it is. So it defines some like embedded OpenGL functions, specifically some that lets us get like textures, turn a like external image into a texture and like use it directly. That thing is, oopsies, sorry. If we paste, search, that thing is part of our OpenGL core profile. So despite the fact that it's defined for OpenGL ES, it is like valid for us to use this thing. However, GLAD doesn't know that. GLAD is like, this is an OpenGLES function, not a fucking GL function. So you have to include the GLES loader instead of the GL loader. And then like, you can't do both. You have to use one of OpenGL or OpenGL ES because they're like different APIs. And I don't think you're supposed to use both of them at once, as far as I understand. And so we're kind of at the point where it's like, we could, live with it. Or we could just write our own OpenGL loader. Let's just write our own. We can do that. Surely it's not that hard, right? There's a big chunk of XML somewhere in this like OpenGL. Where were we? In this OpenGL registry repo, there's like an XML folder. This is owned by Khronos. This is like the fucking ground truth, baby. And you like open this XML file, and it's like, there's like things in here. This is like, you know, you look at like toDoes, the function we're trying to do. And it's like, oh look, we have like a prototype in here. We have his like return type, we have his name, we have like his parameter types. Like we could generate some fucking bindings ourselves. Surely. So let's just try it and see what happens. They even have the gen boiler thing you can just if needed. Let's start from scratch. Right, so they have, I think, in here, they might have some, like, Python scripts. Somewhere, I think I saw some Python scripts. Maybe in here? Gen GLVND? Maybe something like this. I don't know. Let's just, let's poke and prod and see what happens. Gen, this is a script. Yeah, okay, let's just clone this repo and start seeing what happens. That's the wrong button. All right. Git clone this thing. Can we do a shallow clone? Oh, even that is expensive. What the fuck is in this thing? What is this repo? Crazy. I thought this was just a bunch of, like, specs. Alright, one sec. Alright. So, can we just poke around in here? So they do have, you know, they have the C header versions of these things. Wonderful. This header is generated from this thing. And generator scripts that can be found here. Wonderful. Right, so presumably their generator scripts are like, I wonder if it's this. We can try running this and see if it makes the same thing, right? So probably gen headers is what we're looking at. Do I have Python? Probably not. Don't you love 1,000 pages of specs? Yeah, hell yeah. What does this thing need? He is pretty much no dependencies here. What about here? He has LXML, which might not be standard. Yeah, that's external. But otherwise, I think everything is system. So Python 3 and Python 3 packages LXML. All right. Can we just run this thing? Gen headers. And he just goes straight into there, right? So, he like, we have GL in here. If I just like delete some files in here, I assume that this is going to work. Right, so I deleted those guys and they're back. Right, so it does look kind of like this did what I wanted, except that we're missing something about this is wrong, right? Like the fact that everything is fucking missing. Right? That seems bad. What is this? I assume this guy maybe wants to take in some arguments, maybe like which XML files that we're looking at. This guy does do some argument parsing. Oh, this guy does too. So we probably want registry here, right? That's what like this script is doing. So we probably want like Python 3 gen headers registry GL XML. And then did he have like multiple registries on there? For these guys. I guess also like how much do we care? You know? Like how much do I care what these guys do? Probably not that much. Probably not that much. It would have been nice just to check, but I would just like to, here they have a makefile. Wait. Make. Hold on. GL headers. Okay. So we have // API make API GL GLH. Really? API is // Oh, gl.h is not one of the things that this defines. Shockingly. Oh, because gl.h is maybe the original header. So we don't have to generate that one, but we do have to generate like glx or something. I see. Oh, Leonte, thank you for the 10 gifties. Much appreciated. For C or C++, Surf4 uses Zig. I'm gonna generate something for Zig eventually. Sure. I don't really care enough to figure out how to use their scripts, but I think that like the idea that this is enough to generate is like kind of interesting. Can we just like rip through this GL header and just kind of see what happens? Like, so we know that we have enums. We know that we have extension, command, kind, enum. What else is in here? Skimming, lots of enums. Surely somewhere they have like function prototypes as well. Command, which has prototype, right? So commands are in this like commands section. Cool. And then if we have like, GL gen buffers, this is just a thing in the command section. Sure. Surely. That write an OpenGL loader point gives me PTSD. Is it that bad? Is this a bad idea? It seems like a good idea so far. But it might turn out that we're idiots. But let's just see. Maybe if it turns out to be too hard, we can always decide to use GLAD. Okay, so this is going to be part of our standard library, probably, right? Because we're gonna have to use this in our render stuff. So also somewhere we have an XML parser that we've used for generating Wayland bindings. So we can see if this thing is like good enough. And then maybe let's actually do this in a new project temporarily. Just to like, avoid freaking out too much. Do you want spoilers or do you want to get to the pain naturally? Probably naturally is more fun. Oh, let's do it naturally. But appreciate. I don't know if it's like frustrating for you to like see us not know, then that's like one thing. But maybe it's fun for you to see it. And in that case, I'm happy to go in blind. Oh, it's actually called XML parser. Wow, we were fancy with it. XML parser. So can we just start by like, I don't know, trying to So I'm just thinking. So we have gl.h. We don't have to worry about that. We're only looking at like newer OpenGL functions that don't exist in gl.h naturally. We know that these functions. Yeah, we are only trying to do the loading portion. Okay, so that's useful info. So we probably want to start with like glxt or something and figure out if we can parse that thing. So can we just like, first of all, we need to be in a proper environment with like Zig and shit. Let's just do this for a second. Glad in Swedish means happy. Same with English. English has that one too. All right. So can we just do like, return error hi, just for a second. Zig run main. Cool. So now can we be like, parser is XML parser. I assume that this thing gets initialized with a buff and a file. I assume that this buff is for reading. This is pre Zig IO reader, so probably there's a reason that we did this with the intent of reading from file in chunks and inspecting, making reference to the buffer data as it is in memory. Okay, sure. So this thing is like unnecessary now, but whatever, we can keep it for now. So var buff, can we make this thing like, I wonder if, 4K is big enough or if this thing wants to get a little crazy with it. I don't know. But we'll see. And then this guy wants a file, so we want like f is stood fs like this. Current working directory, open file, and it's like .. OpenGL registry XML. Can we just do like extensions? Let's just do gl.xml first, and we'll kind of see where it takes us. Sure. And then can we go like parser? How does this parser work? Who knows? Next. Sure. Can we just print what we get? Like what does the thing return? An item who's got all sorts of stuff. Item type. Oh, okay. Name. Oh, this is annoying. We should clean this up and use the stood IO system now that it exists. This is like, I see why we did it this way, but it's annoying. But for now, maybe we can get away with it. If we look at item name or something, maybe we make a hash map of these things. So can we go like stood? I've seen you writing an XML parser before to something similar. Yeah, this is that XML parser. This is exactly that one for the Wayland bindings generation. Schmitty, thank you for the 100 bits. Much appreciated. Okay, so can we do like stood auto hash map of this to void, I guess? Auto string hash map like this. With some alloc, can we just do like, for now, var GPA is stood, keep general purpose allocator. Do I want, it's like we might as well pull in stud. We might as well. We might as well get crazy with it. Git submodule add backup. No, git stud. There we go. Might as well. We might as well. We need a build zig zon for us to be able to import stuff. So this is GL loader. Say we use zig 15. And we depend on stud, great, and fingerprint is undefined for now, which I guess means we need to build zig. Oh my god. Oh my god. Okay. So we have stud dep is like B dependency. Stud, we have stud is a module that comes from a dependency. And then we're like, you know, we have some executable, add executable, who's got like a name, GL loader or something, who like references this module, who we create with b create module. Boom, boom, boom. And he's like root source file is main.zig for now, and then target is, I don't feel like supporting things properly right now, so we'll just write this. We'll just do it like this. Okay. That should be enough. We need to do exe add root module add import of stud. And then we should be able to like have our allocator system. He's like fucking drop a fingerprint in there. Okay. B path here. Oh my god, my P key's falling off. Okay. So now we can go like we can get crazy. We can just use stud alloc buff allocator, sure. With stud keep page allocator alloc. Can we do like just a meg? I don't give a fuck right now. I don't give a fuck. Scratch, we'll call it. Boom. And then we can use stud util. Whoa. Where's my hash map? Where's my hash map? Sphalic whip. Util. There should be a hash map in there. Oh my god. There we go. Boom. Oh, we don't support string hash maps yet, though. Let's fix that. There's so many things to fix. So how does this work? String context. They just fucking call string context. And then this thing needs to be re-exported in util. Wow, this is fun. We've never used strings with our hash map before. Maybe it's fucking broken. You will never know. Cons of this is no alloc. String hash map linear, which means that this has to get exported in no alloc here as well. There we go. Okay. What fun. String hash map linear. And this thing actually only takes value here, because key here is already defined as const wait. Wonderful. We're mapping these things to void. Oh, good, you're here. Good times with Valigo right doing those things in Jai. Oh, hey, hell yeah. Okay, scratch allocator here. How many elements are we expecting to see in here in terms of like item names? Maybe like 10,000, like 1,000 to 1,000,000. Surely we aren't gonna have more than 1,000,000 definitions. I have no idea if my hash map works with strings. We'll find out. All right. What's this pissed about? I didn't save. That's a good point. Okay. So then can we do like a defs put item name? And then I guess this item name, like where does this live? When I get this item name out, is it like stored in a temporary thing? It must be, right? Because this name is already buffer. So we like do like a scratch allocator dupe. We don't dupe, we alloc print this thing into a slice. So we're like, we have this thing as two discontiguous buffers. Can you turn them into one and allocate that somewhere? And we'll just kind of discard that thing for now. And then we will put this thing in the set. Boom. Then we should be able to, at the end, just be like, for, you know, def iterator is defs iter, while def it next, we have some item, and then we can print the name. And we'll just see how, this is going to fall over probably in many ways. But that's the fun. So print this, and we have item.key. And let's just see how fucked this is. Whoa. For Hasbro, you can take the Zig test suite to plug your implement to check for the compliance. Maybe. I think it's like not that straightforward because I don't think our API is like a one-to-one. Our XML parser format function isn't like correct anymore. So the new version of this thing takes in a std.io writer, if I remember correctly, just kind of by itself. If I remember correctly. Yeah. Okay. Let's see how fucked we are. So our XML parser is immediately falling over. Start index 10 is larger than end index 9. So this is happening when we look for, when we see element start. What's going on here? So we are like, hey, we are trying to slice from name end to element tag start. So name end comes from here where we look for this. And then element end tag start should come after that, no? Like this should be guaranteed. I guess here then our circular buffer shit is fucking up. What does this return? This returns core dumped. Hell yeah. This returns probably index into the buffer. I assume that this circular buffer is supposed to be kind of written in a way where we expect, like, how do I say this? We expect to be working with like indexes into the buffer related to his like logical head or something. Can the circular buffer handle 10,000 child elements? Well, I think that this thing is only trying to handle like one tag at a time. I think. But yeah, there could be a bug there. But it looks like he's like found something and then he's crashing when he's trying to like slice this thing. So he's like, hey, I'm going to return two buffers. Half of this is going to come from like one section, one's going to come from the other. And here he's like, end is less than or equal to a len, where a is the first half, right? But then end is less than start here. Yeah, that seems bad. Right, is that where this is failing? Oh, no, it's here. He's looking for 71. It's here. Okay, can we just do like a std debug print here of name end to element tag start. I don't know what these things. Oh, element end tag start. So I don't know what these things are right now. We kind of have like element start, element end. Oh, sure. Oh, yeah, this is just fucked, no? Element end tag start is looking for end sequence. Oh, sure. So he's looking for one of these. So this is like trying to parse something of the form like hello, right? And he is trying to find this piece. Sure. And so like maybe he didn't find it because the buffer's not big enough. That's like a very real possibility. Right? So what does this do if we like fail? Index of pause returns null on failure. This returns null on failure as well. So he found something and he's just failing to slice it. I guess maybe like there's, it could be that there's like a fucking bracket in the name somewhere. Like if they have like an escape bracket, that might fuck shit up. Because the name end is, oh no, that should be fine. Yeah, okay. Can we look at where we failed? Maybe that's kind of the key here. Let's do that. Std debug print. Let's look at wait, where are we failing? It's down here. Okay, and then can we look at the buffer that we're trying to print here? So it should be like name and element end tag start and then buff slice. These are like the things that are involved right now. Okay. We should probably new line here and do like hello. Something like this so we can see it. Hello. Right, so we're here. He is saying that the element end tag start is at 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. And the name end is at 10. Oh, because he's expecting white space. I bet other XML parsers are crashing. No, ours is really bad. Ours is really bad. It's probably that he's expecting a space here. Name end. Is like looking for index of any pause of ASCII whitespace or this, probably. Okay, cool. So that got farther. Now we're ooming somewhere. In our... Whoa. I'm sorry. What? Our name must be parsing it correctly, because when we're trying to then index this thing, we're like, here, this Alec is ooming, which means that, like, oh, we should only, I mean, maybe because we're using duplicate names, right? We should be doing, so we need to turn this thing into a slice. Can we do this on the back allocator at first? Then do a get or put here with name. Right? Then if it found existing, or if it didn't find existing, we need to like replace the key with a proper allocation of this thing. And then we do like, yeah, can we do like a back allocator? Is like scratch back allocator. So this is like our allocator. We like pre-allocate a huge chunk of memory, and everything that we're like trying to keep will kind of like be in here, and anything that we're trying to discard will like start here, and then like we'll kind of like allocate in here for a little bit, you know, for temporary storage type shit, and then copy it over if we need to. So even here, we don't even really need to use the back allocator. We could use like a on stack allocator as well. That would work as well. But whatever. Defer this. There we go. We do shit on the scratch allocator, and then if it is there, we copy to the front. Scratch allocator dupe this thing. Okay. Like this. Okay. Cool. So these are, so it looks like we have parsed correctly-ish. This is a bug. That's not supposed to be a name, probably. But we've parsed correctly. If we've parsed correctly, these are all of the things that we will see in here, which isn't that bad. It's not bad. Okay, so clearly this like name end thing should be looking for an equals as well, right? Even then though, like name and attribute are different. Where is that like version coming from? What is happening there? XML, GL, XML. Oh, is that, so why does that not happen? I mean, maybe that does happen in our Wayland thing as well. Yeah, it probably does. It probably does. We probably just ignore it or something. But yeah, we could get a little bit fancier with it with like XML parser. XML decal here, if we see that thing, for some reason we still return it. Like here we could, that's fine. Item type here is what? Element start. So we could in our main here be like, if item type is equal to XML decal, continue or something, and then we wouldn't see that anymore, probably. Yeah, nice. I don't like the fact that sometimes the name is empty. That seems bad. It makes me feel like we're missing something, like that the parsing is not working correctly. Right? That seems kind of bad. But maybe that's like normal. Can we look at the parser and just kind of say like if name start is equal to name end or something? Std debug print found empty. And then can we print the buff slice here? Or something? And can we do like slice from 0 to 50 or something? Just to like keep it small. Oh, sure. So if it's a comment, then of course there's also no name. Right. Right. So we should also be discarding comments. Or item type is equal to comment. If name starts equals to and prefix type is not equal to comment. Let's try that. There we go. Okay, cool. Although we still in main are seeing some names that are like this is still here, which is a little concerning. Can we like, is this like does he have some length in here that's not 0? No, he's length 0, so what the fuck? Like, that should never happen, no? Because we're not seeing comments? Oh, yeah. Okay, let's do this. If item name len is equal to 0, oh, we actually had a make contiguous in here. Oopies. If name len is equal to 0, std debug print item type. Like this. What the fuck is going on here? Element content. Oh, sure. So we should only be looking at the name in some scenarios, probably, is the right answer here. Right? If it's just like content, then we should be pulling out the sart. Sure. Sure. Okay. So that gives me some confidence that we're parsing this stuff correctly. Right? The XML parser is probably doing the right thing here, and we probably only have this set of things, which maybe is fine. Maybe is fine. Cool. So I guess we have to start actually looking at the structure of this XML file and figuring it out. XML GL XML, is that where we are? So we start with a registry. Everything is in the registry. Great. We ignore comments, I guess. So probably we have to maintain some sort of like stack or something. Right? So as we see things, we want to build up a stack of what we're in, right? So if we're in the type section, we should expect to see a bunch of types. And do we have like attribute iterators on this thing? I hope we do. We must, because for XML, for the Wayland stuff, we must have needed it. So let's just kind of start at the top and work our way down, I guess. So we can call this like our tag stack. And we're probably like a runtime segmented list, linear alloc of names? Maybe? Right? That seems kind of reasonable. And let's say like we expect to get like 16 deep, and let's actually just like fucking hard cap it there. You know, fuck it. Alec, what is this? We want like 16 of these things. And if we get deeper than that, then like go fuck yourself. Surely we're not getting that deep. And if we are, then we have something to look at anyways, so. Here we should be able to go like, I guess we say if, so as we get through this thing, we're gonna switch on item.type, right? And if it is element start, we're gonna do one thing, right? We're gonna look for the name, and we're gonna like add this to the tag stack. right? Append bounded here. And this does not, we're actually doing this. We are, oh, this is interesting. I think we point to the same memory. This is kind of funny. Figuring out where to store this shit is confusing, but we can store it over here. We could also attach, we could do proper allocations here, but whatever. Can you explain what he's working on? I've been here for 5 minutes and don't understand. Okay, yeah, so OpenGL, we're basically trying to parse this XML file and turn it into something sane, like C code generator or Zig code generator. We're trying to use it to eventually get somewhere where we can use an OpenGL library that has a bunch of extension functions kind of easily. But step one is fixing our XML parser and trying to understand what the format of this data is so that we can generate the prototypes that come from it, right? In this file, there's going to be a function gl gen buffers, right? And this is a function that looks like, void gl gen buffers takes in a gl size I, n, gl uint star buffers or something, right? Something like this, and we are trying to parse this XML so we can generate something that tries to load a function named glgen buffers if it exists with the correct prototype. Hand wavy, and then because we're fucking masochists, we're using our own XML parser that we wrote because we want to. And our own hash maps that we wrote ourselves. We're just we have our own system that we're trying to make work. Okay, so as we see things start, we put them in the tag stack. And this is going to come from maybe key. Boom. If we see the end, we are hoping that this thing is the same as what is in the tag stack at the bottom, right? If we don't see a matching tag, then we fucked something up, right? So we just like the taste of dog food, nothing wrong with it. Yeah, when at my last job, my my boss told me that I had to test something, and I was like, I'm gonna tell everyone that you told me that you made me eat dog shit or something. Just what are you talking about? I was like, well, I'm dog fooding because you told me to. You're making me eat it. You said I have to do it. He's like, oh my god, stop. Please. Okay, so this string that we have should be the same string as the one that is on the bottom of the tag stack, right? Do we have last elem? Get last? Yeah. And then we pop this thing off the tag stack, right? We just do tag stack pop or something. And then everything else we don't give a fuck about, right? So if this succeeds and we have pretty good confidence that we're parsing correctly, good news, no crashies. Good, no crashies, no crashies. And so what do we do now? I guess we use this state to do something, right? So we probably have some sort of state machine probably that's keeping track of what we are trying to do right now. Yeah, so we're we have a purpose depending on where we're at, right? So for types, we just define each of these. Do you guys think that include khr platform.h is a type, or do you think that's fucking insane? Is that crazy? I don't think that's what a type is. Okay, and then it looks like the structure of these is... Dude, come on! That's not a type, man. That's not a type. And then also, here, name is an attribute, but in every other one of these guys, name is like a subfield. Right? But I think we might get lucky in that we don't actually have to do any of this. Right? It doesn't actually matter, because if we're trying to write a loader, what do we care about? Like, we can assume probably that all of these types are already defined for us in the GL and GLX headers, right? We only care about functions, probably, I think. I'm going to make that assumption for now and then bite my ass later. Okay, I'm not going to bite my ass, but like, you know what I mean? It will bite my ass later. It worked with our generator. It's so funny. Yeah. So really, like, what are we looking for here? Let's go back to whatever our problem was yesterday that we were hitting. That's kind of like the important thing to look at here. So we fucked up our stud library. This is all garbage code that can be discarded. Okay. Fuck everything that we did yesterday. So now if I go into here and I try to build, we should see like some linker failures. Nice. So we can just start looking. So we can look for GL create vertex arrays. This is kind of like the main thing that we're trying to look for. This is the problem we are trying to solve. And so in this command block, can we just like, can we save the tag stack instead of the, it's fine. It's fine, we'll just scroll up. It's only like 10,000 lines. How far back could we be going? So commands are in commands. That makes sense. So basically, until we're in the command section, we don't give a fuck. I don't give a fuck. Sorry. And even then, we can probably assume that any command is in the command segment. So really, we just want to know like if we're a command, right? So this is going to be like, I guess we have parser state where we're in a command and we're not in a command, right? That's kind of like our two parser states that we're going to care about, I think. Right, this is like in command or not in command, right? And this is like not in command. And so if we see the command, so we like go into element start, and if like we might not even care about this tag stack, to be honest. We might not even need this, right? Because we're just literally like if switch on item type, I guess we're in an element start, we switch on parser state, and if we are, I think it's the other way probably, we switch on parser state, and if we are not in command, we are looking for you know, we're looking for an element start where name is like command. Else we don't give a fuck. Right? So here we're like, if studmem equal name with command, we say parser state is in command. Wonderful. Then if we are in command, we're looking for like an element end of command, probably, right? We're gonna assume no nested blocks for now. So it's kind of like this, right? Probably. I guess here if the command self-closes, it might not have a name field. So we might want to maintain the tag stack either way. However, we've proved already that the element ends always have a matching element start. So there are no self-closing tags to worry about, or else we would have crashed. So I think we're chill there. And so here we can probably kind of just like not do any of this stuff. Probably. And now what I want to do is I only want to append things to the like set of things that we're looking at if we are in command. Right, so I kind of want to do this. And now we should see a list of, fuck. Where do I just have a stray K here? I'm hoping to see, only, names of things that are in command blocks. Nice, right? So we see here, proto, name, param, p-type, glx, alias, and this thing. So if we go back to this, like, XML file. Nice. Nice. So does that match up? Proto? Name is part of proto, or part of, you know, param. We've param here, who has p-type here. glx is its own thing. I don't know what that means yet. What is, like, alias? Okay, that's interesting. So this is just, like, literally the same fucking function. And then what the fuck is VECE quiv? Vector equivalent, I guess, right? So they're saying here I have binormal 3b x'd, and then there's also binormal 3b vectored x'd, where I assume that like this is like its own function, and here he's saying I have, yeah, this is like metadata, right? So we don't care about this. So this is I don't give a fuck. Alias we probably also don't give a fuck, right? So we really only have to care about like proto param p type, which is great. That's not that bad. And he asserts and zig, yep, that exists. Yeah, seems fine. And then, so the only thing to worry about probably is like if they have name attributes as well. So I would love to also rip attributes. Surely we have attributes in our XML parser. I don't see how we could have gotten away without having those. So like, how does that work? Oh, this attributes is just part of this thing. Oh, sick. Okay, so can we go like, okay, so our parser state is going to get a little more advanced now, I think. We're going to have, you know, default, proto name, param type, param name. And I think that's it, right? So we start in default state. And if we are in default state, we are looking for command. Right? And here we go to, I guess this becomes command, right? And then all of these guys should be like prefixed. Like this, I guess. So we go to command state here. If we're in command state and we find element, we find command and we leave command state. Cool. And I would love to actually just, I'm sure that there's some sort of like Uh, we could create some mappings here for sure, right? It's like here we have some sort of like, what is it? Meta enum array. Enum array here where we use like parser state. I saw a clip from a stream at some point where the guy was saying AC/DC's an American band, and his chat was like, no, it's Australian. And he's like, they may be Australian, but their music is fucking American. And every time I hear AC/DC, I think about that now. It's like one of the funniest things I've ever fucking heard. It's like so true. It's like the music is, yeah, it is American. Okay. So here, can we just look for like the relevant strings, right? And how do I like initialize this thing? No, refuses to elaborate. Yeah. I said that there was an assert. I said there was an assert. If that's what you're talking about, I don't remember. I don't know. Can we just say like we want like our we want our like enter names, like the things that we care about, right? So it's like enter names. I feel like it's like command command proto name param p-type name or something. Oh, sorry, with the AC/DC guy. Oh, gotcha. And then surely we can like use this in some way, right? We want like, you know, it like matches entry name. And then we can kind of like take all of this, right? And this is going to take in like an item as an XML parser iter item, maybe. And name is like U8 here. You know, something like this. This is like should enter. But even then, it's more like, no, we kind of want something more specific, right? We want to be like in default state. Default mapping is, it's like this, where we have like, this is like a list of structs that map from name to parser states is maybe what I'm looking for, right? And so like in the default mapping, we see like command to command, right? And then like in command mapping, it's like we see proto and we go to command proto, and we see param and we go to command param or something. And then if we are in like proto, yeah, it's like something like this. And then is there like a way we can easily rip this here? So here we're gonna have like mappings, and this is going to return an optional of a parser state, probably. That seems kind of reasonable. So yeah. So then he iterates over all the mappings, which go from like, can we just do this? We'll go from strings here, so like names and states. I think this is the reasonable way to do this, right? Then this is easily callable externally, and here we assert that names len is equal to stateslen. And then here we're like, for names, if we equal this name, so this is like item name. Can we just do this? Item name here. Item name at like, I guess we'll already have parsed this thing. So we'll do item type here as item type here like this. And then we'll have like item name here. There we go. Okay. Boom. We return states at, I guess it's just state. Boom. All right, then we return null here, and now we have like a nice little, like next state. Yeah, we can call this next state here, and then we can also handle the end, right? Like this could be enter states here and exit states, or something. Not sure. Handle enter, like should enter or something. Okay, let's see how this works. Let's see how this works. So if we are in default state, we're looking for if should enter item type name should enter your mom. Thank you. Thank you. We're looking for only command, right? And this is going to go to command. Or something. Right? Something like this. So this is like, this is like new state. Parser state is equal to new state. Okay. And then that makes it so that we can kind of handle the rest of these really easily, right? So now in command state, it's like if we see proto or param, we go to command proto or command param, right? If we're in command proto, we're looking for name only. And if we are in command proto name, we don't do anything because there's no entries there. What else do we have? We have command param name and command param type. Okay. So we're missing command param though, right? Yes. What are you building? We are working on generating bindings to OpenGL for, you know, how do you say this? Like some functions have to be dynamically loaded, and we are trying to write something that will generate those based off the XML of the OpenGL extensions. Something like that. We should probably double check that glxt looks the same, huh? Oopsies. Well, we tried. I give up. So if we see name or p-type here. Whoa, wait, am I high? proto doesn't have, oh yeah, proto or param, great. Param has name, or proto has name, param has name and p-type, great. And then in reality, wait, yeah, I think it's fine. I think it's right. Okay, so we never leave these states, which is bad. So I guess should leave is just that the it's a closing thing and the name is our name. Right? So it's like, you know, if item type is equal to element end and name is param, you know, we like parser state is equal to command. Right? So I guess this could be a function. This is like should leave item type is an XML parser item type and the name is this, right? This is like item name and like tag name or something, right? And we just return this. Right? And then this is item name and tag name. Cool. But Jack and Knight later. So now we have if should leave name and param, we go up a state. And we just have to do these for all of these guys, right? So here we're looking for name. This goes to command param. Here we are like, if we see p-type, we go back to command param as well. And then here we go, if we're in command proto name, we see name, and we go back to command, right? And here we should see proto. We go back to command as well. If we see command, we go back to default. And I would love to maybe print the name of every command, right? So we should be able to do that now. If we're in command proto name, we should be like, if item type is equal to content, we should be able to print it, right? So how does this work? How do I look at the content? I think it's just start to end on buff slice. Do we have that somewhere in here? He has attributes, name, type. Is start and end the position in the total buffer? What is start and end in this thing? It's in like self buff, I think. Unless it's in buff slice. Hold on. Iter. Next here, start pause comes from self buff. Yeah. What is content? Oh, sure. I see. So we're like, supposed to, I guess, this is not a very good API. I'm shit at writing code. I wrote some garbage. I'll fucking say it. But we should be able to be like, parser buff content, and we should be able to be like, name is buff content. Whoa, how do I, whoa. Is slice exist, but it's not public? Yeah, it is. So we slice from item start to item end. And we should be able to print the name here? I think this is how this works. This is proto name, I guess, so we don't name collide. Fuck. That's not good. Can we log our transitions? Oh. Let's get into this. Okay, so this is pissed. I assume that that's due to my logging. I assume that this is my slice here is pissed. Yes. Okay, so if we see this thing, can we try to figure this out? So can we clamp this maybe? Can we take the minimum of this and like 15 or something? Whoa. Oh, okay, so this is the start and end in the fucking content. Yeah, this is not start and end in the buffer. This is start and end in the literal file. I see. So this is not the right way to get this information out. Interesting. So this thing is designed to be used with a file. I guess maybe the intent is that we extract these things first and then go back for a second pass in the file for things we care about. That's really strange. That's a strange API, unless I'm missing something. That's crazy. Good job, me. That's crazy. Yeah, start pause. It looks like there's just no way for us to read the content from this, which is crazy. Because we must have it. I think that's like an oversight. What do we do in our Wayland generator? Like, this is confusing to me. Like, in the Wayland generator, we might just not use it ever. And so this just didn't come up. That seems kind of likely. Oh, wait. Yeah, okay. So we did just read this file first, but then, like, isn't this invalid? Like, when we start iterating this thing, won't he be like, yo, bitch, we're not at the right spot? I guess maybe read to end alloc happens to, like, maybe that happens to be okay. Like, it, like, maybe resets the file positions or something. All right. Whatever. I don't really care that much. File content is f read to end alloc with scratch allocator. Which makes me think that this is going to have to get bigger. But I guess we'll find out. Okay, so now we should be, wherever we were trying to print the names here, we should be able to be like, file content from this to this. All right. Read to and Alec. He's got a max size. All right, yeah, not big enough. File too big. This is a big file. Okay. Hello? In proto name. Am I high? That never happens. In default. Are these like not working? Yeah, what the fuck? Oh, I mean, do I have to seek 2.0? Maybe? Maybe it's just like not parsing the file at all now? Yeah, there we go. Okay, there we go. So can we go back to seeing if we see our names? We do! Look at that shit. I'm a little concerned that I'm seeing things that aren't parameter name, like function names. Are we going from, yeah, command param goes back to command param. This is a little scary. Can we look at like GL draw this thing? So somewhere below this, he's going to like n and arrays, right? So he's printing parameter names for some fucking reason when he shouldn't be. He should only be printing prototype names. So what the fuck is up with that? Are we like... We're working on the GL loader right now? Yeah. Yeah. Command param switches to command proto name instead of command param name. Yeah, it does seem like that, huh? It's in exactly the place that you would expect it. So, I don't know how the fuck I missed that. Good shit. All right. So this is good. That seems like we have a list of functions now, which is pretty cool. Okay. So now we just have to generate some code to load them, maybe? Right? Like, I'm surprised that our XML parser like succeeded here, by the way. That's kind of crazy. Like there's so many like stupid constraints on here. Like it can only look ahead 4K and like it's shit. Okay. So can we kind of try to generate function signatures now? So I think if we understand this correctly, when we generate, okay, let's do this. Std debug print on entering to, I would like to actually do something like this. Function switch state. So we're gonna take in our, maybe we're gonna do like move to, other. This is kind of like a silly way to do this, but it's an easy way for us to inject custom code, right? So if we are like self and we are like entering, I guess it's other, if we are entering command proto, we can print out I guess nothing. It's like if we're entering command, if we're leaving command proto, then we have to open a bracket, right? It says void name, then like here we want to put a bracket. Right? Something like this. I'm trying to print the prototypes in like C style. That's what I'm trying to do. If we are leaving command, we probably close the whole thing. And then otherwise we print any content we see. Right? So you get void here with a space, name. Then we print our bracket ourselves. GL size I space name. We should put commas between parameters. So if we're leaving command param, we put a comma. Maybe like this. Right? Because then I think that makes sense. And then otherwise we just print the content. So now we just make it so that every time we do this parser state equals, can we just do this? Parser state equals. So can we do find equals, replace with parser state move to, put a bracket, jump here, boom, fuck. V word S parser state move to, find this, hit next. Okay. There we go. Okay. So then I just also want to unconditionally print content, right? So if item type is equal to content, we print it like this. So we kind of, I think it's just like this. Boom. Okay. I think an also and parser state is not equal to default, or else I think this will print out way too much. Okay, so then here where we did this, we do else do nothing. He's mad at 36. We need to dereference ourselves. I think it's wrong. That is my suspicion. How close are we though? Oh, because move to, it depends on if we're going up or down. Yeah, it's like if self is command proto and other is default, that's when we do this. Right? Oopies. 1,000 smiles looks like success to me, yeah? Yeah, I agree. He's very happy. Else if self is command and other is default. Didn't we already do that? And other is command. This is this. Boom. Else if self is equal to command param and other is command. We print a comma. Okay. Let's try that. feels a lot closer. A lot closer. I feel like we're missing something. We're missing like entry here. If we're going in? No. You lost all the opening prints. Yeah, I agree. But like, are we not ever going from command proto to command? Surely, right? Right? It's right here. And it's the only way that we leave, unless we go from command proto name. Oh, yeah. My bad. Okay, so that brings us back, that gets us our opening parentheses, but then what the fuck is going on with this like billion fucking semicolon at the end? So it looks like relatively okay. Like most of this looks like kind of right, ignoring like the fucking indentation. It's just at the end, we just have like a bunch of shit. So it looks like maybe there's this stuff, right? So we're entering command. So we should first check that we're in the commands block, is probably the only way, right? So there's commands that show up other places that are not this. Right? And so that's why we're seeing a bunch of shit. So our command state. So we go to commands first. And then if we're in what is it? Commands like this? Yeah. Parser state, move to default. Great. Then if we're in commands, we look for, oopsies. In commands, we look for command. And then in command, we go back to commands. Okay. That's looking pretty good, except for the close parentheses now has to happen on movement to commands instead of the default. There we go. There we go. That's not bad. Why the fuck is this happening? Like, it's probably like we're printing this stuff somehow, right? Yeah, as we're printing this because it's part of the command block. So, and parser state is not equal to default, and parser state is not equal to commands, and parser state is not equal to command. All right, that's better. That's better. All right. I mean, that's pretty decent, right? That's, I think, all. Oh, yeah. I think this is all the information that we need to generate loaders if we need to, right? Well, I guess there's probably duplicates in here, right? So there's probably stuff that, yeah, extra commas. And if you listen, yeah, I don't give a fuck about that though, because in Zig it's allowed. In C it's not, but in Zig it is. Okay, so I think that there's a problem here where we don't know yet which things are extensions and which ones aren't, right? So how do we deduce that, right? So we know that we have our one failing function somewhere. We know GL create vertex arrays. We know that this is bad, right? So does this talk about, like, is this in a block of like extensions? Like, how do we know the difference between this and like GL gen buffers? You know? Like, I assume that these are in some sort of block that tell us which OpenGL version that they're associated with. Right, so even probably a layer up from here even, we're probably, like, these are probably like extension enums and shit now as well, right? Back. Maybe not. Yeah, is it really not? These are all enums all the way up to the top of the file. Okay, GL gen buffers. This is down here. Versus this function. Oh, wait, maybe this is it? Ah, so it's in the feature sections. I see. So it's like, depending on here, like if we have direct state access, then this thing comes in, or if we are in GL version 4.5. Okay, so can we like GL gen buffers, right? I think that this is kind of like a base level thing. GL 1.5. I guess like theoretically it doesn't matter, right? Like, there's nothing stopping us from dynamically discovering things that already exist. Probably. But then also, we don't have to generate loaders for everything. We probably only have to generate loaders for the functions that we want to use as well, right? So like in reality, we can pre-inject the names of functions that we want to create loaders for. And then it can be like a really stripped down version of this, right? It can only be a few fucking functions. And then we just use those that way if we want to. Yeah. And then it would be ideal if we could like combine the translate C of GL with our shit, which I think we can probably get away with, right? By just appending to the file. So we call like translate C on the original headers, and then we just like huck our shit on top by appending to the end. I think that'll work. I think that will work. So all we have to do is maybe we have some sort of like input. For now, I'm just going to make it a JSON blob because that's easy. But we can kind of say like, you know, wrap like proto, like desired protos or something, right? Is just a bunch of these guys. And then we can say protos JSON, you know, this. Then we like open that thing. Proto desired protos is stood JSON parse from token source leaky. Boom. Like this, boom, boom, boom. We have our JSON scanner, and we have options. Okay. Can we give us the back half of our allocator? Back linear. We go like, const checkpoint is back alloc checkpoint defer back alloc restore checkpoint. Now we use the back allocator for our token source, or for the scanner. Hello, reader? Okay, maybe like this. JSON reader. This guy needs an allocator, so we're gonna use the back allocator here. I assume that's okay. I actually don't know. Because I assume that if we're saying use this allocator for our output, I assume that it copies things if it needs to. But I don't actually know. I think that the parse options, have allocation behavior. This determines whether string should always be copied or for reference from the given buffer should be preferred if possible. Yeah, so we just say, yo, alloc always. And then that means it'll copy things out of this scratch space when desired. This needs the IO reader. So here we have the IO reader. I guess it's like we need to open the file, which is open file of protos. There we go. Nice. Var reader is f reader with back allocator alloc, 4K maybe. Interface here. Okay, I think we're pretty chill now. Allocating from both ends of the buffer is a neat trick. 2 for the price of 1. Haven't seen that before. Is that a well-known pattern? I don't know. I just did it one time because it pissed me off that I had to use 2. Because it was like I needed 2 allocators, and I was like, that pisses me off. So I started doing it. I think it's okay. I think the back allocator is probably less efficient in some ways because you can't extend very easily. But it's whatever. And I think that virtual memory wise, it's also okay, right? Because you allocate this 50 meg buffer, but things only get paged in as they're used. So in reality, you're paging in from both ends, but everything in between shouldn't be allocated, I think. But I'm not sure. Are we good? Are we chilling? So then we can break block desired protos, and then I have that here. We should have functions, but fuck it. Std debug print desired protos. Let's just kind of see how that goes. He's mad because I need to try somewhere. Expected something, found something else. The fuck? At IO writer. What the fuck? Zig build f reference trace. This is from main debug. Yes. Okay. So this is from a print. Oh, this is here. Any, my bad. For desired proto, is this how we do it? I guess if we print every prototype there. Okay, cool. So now we can check every time that we enter a prototype, every time we enter somewhere, we should be able to check if that thing is the name. So this guy, when we enter the name field, I guess, is when we start checking, right? So I guess what we should do is maybe we like cache information about this thing as we get it and then dump it when the name matches what we want, right? So maybe we have some sort of like you know, LM builder or something. And he starts with like return type, right? He has the params, I guess. Hmm. It's kind of like an array of these things, right? I'm just trying to think about like where this memory is gonna live. Because like in reality, this thing is gonna like grow and shrink outside of this loop now, right? So really, it's more like we might just like re-checkpoint this thing every time we like leave a command or something is when we might restore. Oh, we're also using the back allocator here. So we could, I guess that's intentional. So the front allocator we could reset when we get it here. Because I don't think we're using this like hash map anymore. Right? We're not writing down our definitions ever, right? I guess we are, but we don't need to be. Which makes this make more sense. So now this guy is who owns the front buffer. And then we can just kind of like allocate willy-nilly. Okay, so we have return type, name, right? Params. And is that all we care about? I think so, right? Okay. So here, I should just double check who is using the front. The only people using the front is desired protos right now, and the file content. Yeah, so we're chilling. Scratch, linear. Oh my god. Okay. So every time we go back to the commands block, here we check if we let's like print the LM builder, reset him, and reset the allocator. Right? Something like this. I don't know what this looked like before. I always feel like when I accidentally reset, everything gets like fucked. Okay, and so now instead of like in move to printing this stuff, we're going to log the stuff we care about in like particular states, right? So first of all, if we run this right now, we should see a bunch of nulls, except for the fact that we're printing here as well. Okay, so let's do something like when we see, if we are in proto name, right? And we see item type is equal to content. We just like huck that shit into LM builder name is equal to file content from item start to item end, right? But we need to copy this. Oh, we don't even have to copy this out. This just lives in the file. That's like, this is an own buffer, which is hype. The fuck? Why is this only printed once? Oh, because it's leaving the commands block. This should be on command leave, I guess. Not commands leave. There we go. There we go. Okay, let's make a better formatter for this thing. Actually, let's not. I changed my mind. Let's. I changed my mind again. All right. Pub function format. It takes an element builder and a writer. Stood IO writer. And here we're like, I guess we just start ripping this shit, right? So we're like, if self writer print turn type, if is it really just like this? I guess it's like, is there like a null string printer? Right, this is kind of what we want, right? This makes things a lot easier. So then we have like inner is, I don't know if this exists in the standard library, by the way. It just feels like when I print, it doesn't do what I wanted. Which means, like, it's because I wrote any, right? Like, I know that there's some way, like, to make it, like, there's new formatting rules, right? Like, how do I make it to make, like, string fields print as strings? Where does he go to, like, pointer? So he iterates over hello format. Like when, okay, so here print value, here we go. So if I see, you know, so S can be used on pointers and arrays, right? Otherwise it's invalid. But can I like adjust the way that this thing works if it starts printing a struct? O has number as octal. He has format number. So if value is a struct, oh, I see. He calls like a format number on this thing. Yeah, it doesn't seem to me like there's a way to like be like print that shit as a string, I don't think. Which I think, what is this top level switch here? Format length. Yeah, it seems like, well, unless we get down here, is any. We get down to struct, and here's where he puts the insides. And he calls print value any options. Right? So, like, shouldn't these options come in somewhere? Where do these options come from? You know what I mean? Because I feel like these options. Oh, this is all just number stuff, right? All right, yep, okay. So I think that makes me confident-ish that it's fine for us to create our, like, null string formatter. Make a formatting structure or add format to your structure. Yeah, I mean, that's what I was doing, but I was like, do I have to do that? Like, it seems wrong that I have to. You know what I mean? That's all I was kind of confused about. But that's okay. Not the end of the world. So here we go. This is a null string formatter, and it's just like, if, self inner is null, I guess it's like S is this, this is null, else I guess it's more like if self inner ss else null. There we go. And then we could do this. Should I be using print value here? Ah, whatever. Okay, so then here, now we can make this like, return type, and we can use this. So let's do this. Name params. And then for params, we have to get a little bit more advanced, which is fine. So this is like null string formatter, like this. I guess. Ew. Then we have name. And then params, I think that this is actually like array list of these or something. And we go like for params items param, we print something, I don't know. Param, I guess, with I don't know. Null string, I guess this is just a string, param. Okay. Okay, so now we should be able to print our LM builder nicely, like this. And he's mad, no field name format. Did I not make it pub? Or did I not use the right thing here? I probably didn't. I probably didn't set this to the right type yet. Okay, params is try init, but I guess it's just init buffer with try scratch linear or like allocator. And it's like, surely nobody has more than like 16 params. Surely. 171 here. I guess this guy wants a reset now. I guess that's how this is turning out. Self return type is equal to null. Self name is equal to null. Self params clear retaining capacity. There we go. Reference trace. We're like looking at format from 176 here. LM builder is pissed for some fucking reason. Expected tuple found constitute. Yeah, because I just do that all the fucking time where I forget to put things in the squigglies. Although here I feel like it's right, no? Squigglies? Squigglies? Am I fucking high? Main 176. So I have squigglies here. Am I high? Okay, so that's fine. So it's somewhere in this. Oh, it's in this one. I forgot squigglies here. I forgot squigglies over there. There we go. There we go. So params, we are not populating this stuff, but at least the name seems to be getting populated correctly, which is good. We should probably strip the name too when we fucking put it in there, huh? But that's looking pretty good. So now somewhere we have, wherever the fuck we were setting this thing, can we do like stud mem trim, like stud ASCII trim stud mem trim. Oh, here. So this slice, and we trim it with stud ASCII whitespace or something. Probably. Okay. Cool. And then we do the same thing, you know, if we see a parameter. I guess we have parameters are actually of type I'm trying to decide if I care. Yes, I do care. I do care. Parameters are not like this. We have param is a, you know, type, and val, or name, I guess. And we have a similar format thing here. Boom. So this is going to be more like maybe we do type name like this. Okay, cool. Params is a bunch of param now. And I guess when we enter a parameter, we probably like append it to the thing. So when we go into command param, this is not where this should go, but whatever. LM builder, params append empty. This is like should go somewhere else probably, but whatever. What's this about? Expected 2 arguments. Append bounded. My bad. My bad. And then these need to be defaulted to null. Okay. Now someone is pissed because I actually don't know who is pissed now. I probably forgot some squiggly somewhere again. So this is at main 195. Oh my god, so it's like deep in this shit again. It's probably that our printing of parameters is not using the formatter correctly now that we've changed the type. Yep. Okay, and then we shouldn't param type null, name null, and then we've got like an extra comma somewhere here. I guess like this. All right, cool. That's good enough. Sure. And then here, we're actually seeing a lot of the wrong shit. So, what's going on there? Whoa, something's wrong. Like, why? Like, I think that our parsing is wrong all of a sudden now, right? What happened? What happened here? I guess we should say, like, if lm builder name is not equal to null, Print it. Otherwise, like, are we... Yeah, something's wrong here. I feel like... How... Yeah, that's... Something's wrong. Can we go back? Okay, let's fuck this shit. Can we only look at... Does this still work? Hold on. It could be that our parsing was never quite correct. Although, this still looks kind of right. So it's interesting. Let's look at who's assigning to element builder name is a trim of the file content from item start to item end. Oh, but this is when we're leaving. Oh no, so if we see element content while we are in proto name, we assign the name. Can we std debug print here the name instead? I just want to see what happens if we do that. You know? Someone's mad at this thing. Okay, so that's good. So it looks like when we put the names in, they're okay. So then how come when we try to print them, they're not, right? By the time we get here, the names are garbage, which seems wrong. Which means that, like, our element builder, when does he get reset? Only here. There's no, like, allocation shenanigans going on because the file content should be valid forever. Element builder name. He has only looked at... Oh. That would do it. Okay, that's better. I was just accidentally assigning... I forgot I had some work in progress code down here that I copy-pasted. So this is, if I am in command param, I append... I guess it's like the last thing? Items at element builder params len -1. Is this even a thing? No. This has nothing to do... I should not do anything here. Only in parameter type or parameter name do I start doing this. So I say here, type is equal to this. And here, I do the same thing for name. Close. No len. Okay. So we take, like, the last element, and we set the name and length. He's mad because this doesn't exist somehow. So I thought that when we enter the command param state... Oh. Okay. So we out of memory on this thing, which is interesting. On element builder params append bounded. So it could be that more than 16 parameters do happen sometimes. Let's just do 100 here. Surely that's enough. Okay, so there are some functions that take over 16 parameters, it seems like. But now we're starting to get pretty good, right? We see here, GL viewport index f is a uint float, uint index float x, float y, float w, float h. That seems pretty good to me. Pretty good to me. So now the only thing that we're missing is the return type, right? So we should be able to huck that in somewhere as well. That is, where does that look like it's coming from the XML? It's literally just like the first content in the prototype. That's crazy. But sure. That's wild. So if we're in prototype state, we see some content, and this gets appended to the name, because there's other content for proto, right? I guess not really. We can probably assume no. We can probably assume no. So this is like LM builder return type. And I guess we just like this. I'm surprised that works so well. I guess we should also check, like, we should do, like, return type is this. And there's, like, risk of this thing being null, right? So if return type len is equal to 0 after trim, I guess we should actually just do, like, only set this thing if it hasn't been set yet. Assume that the first piece is the return type. So if lm builder return type is equal to null, that is the only time we will set this. And that's good enough for now. Okay, cool. So I think that's all the information we need, right? So now it's just when we exit this thing, we check if the name is in any of the names that we want, right? So like desired protos if lm builder name is equal, it's like if lm builder name, we're just gonna go like nested loops, fuck it mode, if studmem equal this, can we print our shit? Oopsies. Cool. So we have our one thing that we care about, GL gen vertex arrays, and we have all the components. Look at that. Yeah, that's great. That is great. And so now all we have to do is generate our loader. So we probably have a function. What does our like function look like? It's like something that calls like load function with the name and casts it to, it's something of the form like pfn uppercase name is the type. So we have our loader generates things that are like pfn uppercase name, like, loaded lowercase name or something, like easy, simple name, right? And this is null by default. So in Zig, this is going to be like this. Variable, this thing is a, I guess the pfn kind of covers this by default. So it's like var this is equal to this. And then we have some function that is simple name with, param type ... return callconf c maybe? I think we don't need c callconf here, right? Yeah, I think not. So it's like something like this. Ret type. There's a proc in there. Oh, thank you. Thank you. So then we just say, like, we're assuming single threaded here. Which is maybe bad, but whatever. We could do like std debug assert thread something something something, but whatever for now. We say if loaded simple name is null, we do what? It's like loaded simple name. Can we just assume that these things are loaded? This is wrong, actually. I think it's more like we want to do load all. Yeah. Right, and then we just iterate over all. So we say like loaded simple name is equal to load. This is how Glad does this. They take in a loader here. Right? Like kind of like this. And then our function simple name is literally just like return loaded simple name XYZ, right? I think that's fine. I think that's fine. Why do we need a loader? It's because the OpenGL library implements all of GL versions 1.5, 1.6, 1.7, 4, 5, like what 3, 4, 5, right? It implements like a bunch of versions, but not all the versions have all the functions. So like you don't know which version you support until you load the library, and so the loader is like your way of doing like dynamic symbol resolution. Essentially. This seems reasonable. So the types are only needed for this part. So we can just stash the names for use later. And call it there, yeah. So our name list. So with our to end allocator, this doesn't work anymore. So we'll just have like a names allocator. For now, that's good enough. It's good enough. So we have like all. Oh no, we have names already because we know the names based off of the desired protos. So we actually don't need any information about the types to generate the loader function, right? So we can actually do this now. Where you do like stood debug, stood out is what? Stood fs file standard out. How do standard out? There's like stood io get. There's some like new interface for this. I think it is file standard out. Yes. Writer here. Sure. Okay. Maybe to avoid the if on every call, you can initialize the pointers to some function that loads the symbol and swaps the pointer to load one. That's crazy. That's neat. Yeah, you could do that. But instead, I think that I'll just say that you have to call load up front. I'm like okay with making that constraint. I think that's simpler. So this is like function load load. And this is like a const function that takes in a sentinel terminated u8 slice like this, right? And I guess this is more like a C pointer to const u8 is more likely what this is going to be, right? Sure, something like this. And it's like for, I guess this goes up here. For, this is like stood out, print, loaded S is equal to, like, loader S, in quotes. Something like this. Yeah. Proto. I've seen some loaders written in Zig use comp time to construct a struct that only contains function pointers that you actually want to load. You have to specify what set of functions you have to load and compile, then you only have to be able to use those. Yeah, I mean, that's what I'm doing too, but I'm doing it like at the code gen time, just not like, I'm not doing like a struct. I'm doing like global namespace because that's easier. I don't think it's that bad. I'm not super against it. I'm willing to take a hit on a little bit of usability when how do you say this? Like, complexity versus usability is like a balance that we need to hit right, you know? And so like the idea that if I just like write down what functions that I'm going to use, that's not very hard and makes the complexity a lot lower, right? So it's like kind of worth it in my mind. So here, like the idea of like we write down the functions that we're going to use, and then we just fucking say you have to call load, and it will load them all for you, and then they're in global namespace, so that like we can call them like their normal OpenGL functions. Like feels kind of like the right trade-off to me. You know what I mean? Why the fuck? Oh, we need to flush standard out somewhere. Okay, cool. So there is our shit. We forgot some new lines. And then let's also indent this a little bit. Okay. Then we close this thing. So we're fucking donzo. Okay, so we also need to loop over all of these desired protos first and define their variable types. So it's var loaded s is a pfn s proc equals null up front. So this we need proto and can we do like const upper? Proto is stood mem stood ASCII to uppercase string. Nice. Out and proto here. Var, we can say like scratch linear checkpoint defer scratch linear restore checkpoint easy, and then we allocate out upper. It's more like this. Upper proto is scratch allocator alloc u8 of proto len easy. Okay. So far, so good. Whoa, upper string? Like this. Okay. Looking good. All right. So now we have loaded vertex arrays is this. Great. And then all we have to do is for each prototype as we get them now, we should be able to be like, stood out, print. And I guess, can we just actually do like this? So can we just make it so that our print function on this guy returns something sane? So it's like function, name, takes in some stuff. So then he goes like for self params, we write the param. Param now is just like this colon that. And we don't need this null string formatter anymore. We're kind of down to just crash if this doesn't work. I think is an okay behavior in this context. So kind of like this. Fuck it. Sure. So then we print all of our params, and then we just print the rest, which is he has to like print his implementation of this thing, I guess. So he's gonna do like an open bracket. Then he's like going to call loaded name with all of the parameters, right? So here it's like self name like this. We don't have the return type. This is just self name here. We've got the return type somewhere. So here he needs the return type like this. Okay. So then when he's got that, we have to iterate over the parameters again. And we just print the parameter names now. Yep. With a comma in between. Then at the end of that, we throw a semicolon and finish the function, right? So we're just like, finish that thing, enter, finish the function, and I think we're done. So I think this is just a write all. I think it's something like this. So here we have loaded GL create vertex arrays, who is a P function GL create vertex arrays proc, starts as null. We have a load function that takes in a loader. We forgot the return type on the loader. So he will return probably any opaque pointer that we have to convert into the function pointer of our dreams. Okay. Then we have GL create vertex arrays. We fucked up the end of this thing here. We need a close brace on the here. Okay. And so now if we just adjust our prototypes here for all of the prototypes that it was pissed about, it should generate something sane for us. So macro, delete this, replace the quote, comma, delete, go. Oops. Go, 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 go. All right. That's pretty fucking close. He's pissed because type doesn't exist for something, so I guess we go one by one or something. Or we go to main and or else null or something. Okay, so who's unhappy? So we forgot commas between arguments in the fucking params formatter here. But it looks like we have GL named buffer data is a little bit fucked up. So data here. What the fuck? So sometimes there's just no p type. All right. Yeah, that's cool, man. That's sick. What a strange fucking XML. Who wrote this shit? Why does everything else have p type? I guess maybe p type is only for if it's like an OpenGL type. Otherwise, it's like, yeah, it's just a C type. Which means that we are going to have to like map that function type probably, right? It's probably something like that. So first of all, if we are in command param and we see element content, we check if the trimmed potential type is this. If potential type len is greater than 0, we set this thing. Right? Params items at lm builder params items len -1 type is this. And then if we see p type and that thing, if we'll say like const last lm here, right? If last lm type is not equal to null, we'll just fucking crash or something. Okay, so he's pissed. So that is not the way. Can we look at oh no, wait. Oh yeah, so we can say std debug print in p type, but already have type of this. Oh my god. Of const. Fuck me up the balls. Okay. Okay. So we need to like discard const, I guess, right? So we need some sort of like type translation. Oh, that's crazy. Who is this? Who did this? Who did this? So what we'll do instead for now is, oh my god, what is with the fucking, there we go. Okay, so what if we just don't care? What if we just don't care? Does that seem reasonable? Actually, recently I've seen one guy on GitHub shepherding the XML. Yes, this kind of shit, but calling together the historical information is a super service to everyone else I'm on. That's pretty sick. I also saw some star characters in there. No, really? That's annoying if true. So can we look at like which one of these guys do we think like GL named buffer data is maybe GL named buffer data. So this guy I guess I want to know, so who do we think had that const in there? I guess that's what we have to look for, right? Which is a lot of them, actually. Oh, but maybe none of the ones we happen to care about, which is interesting, right? So we kind of have this problem. Oh, here, you know, it is loaded GL vertex array vertex buffer. Oh no, because the flushing is asynchronous. Fuck. Just to keep everything together, I'm gonna do out there. Yeah, so no one we care about has this behavior. Right? So we can kind of dodge this problem for now if... Okay, wait, no. Nope, I'm an idiot. GL create vertex arrays. Let's look at this one. Jesus Christ, man. Are you kidding me? That's insane, man. What a fucking insane... So the parameter types are more just for like linking, right? It looks like, right? It's like we don't actually the parameter type is not the fucking type. It is just the way for you to generate a hyperlink in some HTML to what that thing actually is, right? They're saying you want to know what GLUint is, fucking get over there. But it's not actually the type. So we have to like, I think we just unwrap the p type, append to some array as the type grows, and then like we have to then parse the C type for pointers and consts and shit, rip them out, and turn them into Zig types. Or we generate this thing as C and call translate C on it. Dude, what a shit show. What a disaster. Whoever said that this is gross was right. It's just some random XML tags around certain words in the C type. That's crazy. Okay, so what we do now instead is let's make each of these params, their type is now going to be an array list. Right? And we have to initialize these. It would be nice. Allocation wise, this is like not really, this is like a little annoying. It's easier for now, however stupid it is, to just reallocate. Fuck it. It's just fix me. Should be appendable type, but oh wait, is it actually okay? It actually might be okay if we do... If we make it expandable, I think this will work. I think. So every time we add one of these things, we attach it with the front allocator. I think. even then, we could just do like, no, you could even do this. You could do array list. I think this works, which is easier. So here we go like type is equal to, and we just make a init buffer with a max length. Yeah. That should do what I want it to do. Scratch allocator alloc u8, and the name can't be longer than like 256. Fuck it. I don't give a fuck. I don't give a fuck. Okay, so now as we get this thing, we append to this thing, which is funny. Okay. Append slice bounded, like this. And then we just keep appending if we see p-type. Here. Yeah. Yeah, we just keep fucking appending. Like this. All right. So now, when we look at GL gen vertex arrays, we now have this, right? GL uint star. We have const void star. And so now what we want to do is like, we need to like, for each of the types, we need to parse them and turn them into Zig types, right? That's sick. That's so cool. Is GL create vertex arrays really not a const pointer? Oh no, because it outputs into the arrays. That makes sense. Isn't this backwards? Oh, maybe I'm just like fucking Zig pilled. Yeah, type goes before pointer in C. Just parse C, bro. Smile. Dude, this is fucked. I mean, we can probably get away with. I think that we can probably assume that most of these types are going to be of the form left const type name and then maybe a pointer. And if that assumption gets broken, we can fix it later. Right? So I think all we do here is we strip, we check if it's a pointer. If it's a pointer, we try to figure out if it's a const pointer. Yeah. And then if it is, if we see the word const and it's a pointer, we just assume it's a const pointer. Right? Because the const will always be on the pointer side, hopefully. I guess we'll just check that the const is left of the pointer. Yeah, okay. So let's do like a translate type thing. And all we'll do here is we'll say like, you know, std mem index of, you know, we look for a pointer. You know, pointer index is this. Or else return type, right? Fuck it. We say, yo, keep fucking going from pointer index. And if you find another one, next pointer, like double pointer, we just crash. I don't give a fuck right now. Right? Fuck this shit. Here we say like is const is index of you know, if we see const from type 0 to pointer index, it's like this. And then we just say like function like I guess we care about the const position. I guess we're like looking backwards for white space from the pointer index. So it's like pointer index like index of last index of any last index of none from the pointer index. So we're at the star, which is on like the right side somewhere. We're looking for not white space, right? Anything that is not white space. This is like name end, right? Something like this. Name start is last index of any from name end that is white space. And then we should have all the information we need to like print this shit out, right? So it's like return like std format alloc print with our allocator of what is it in this language? Const x mute or just x, right? Yeah. So star string and like const label is if is const else nothing. And maybe we throw the space in here so that then we can have like type from name start to name end. Right? That seems kind of reasonable. That seems like kind of reasonable. And then when we fucking slap that type wherever the fuck we slap it, it's like translate type. I guess this is kind of more like this, huh? Where it goes into the writer, not an allocator. So this is now just, instead of this is just print. Okay. Don't you also need to convert a void pointer? Yeah, you're right. Yeah. So if the type is void, then we do something else. We'll get there. This thing is pissed because this is the other way. All right. Pointer index, last value of none. Comp time slice. Oh. Type 0 to pointer index here. And this is type 0 to name end here. And then, what's he pissed about? This thing is like this, which means that this is kind of like more like this. And then this is like this. I think it was just a space here? I don't remember. And then this now is like just write the original. Something like this. I don't give a fuck, man. Name start, he can't find him. Yeah, sure. 0. Okay. So let's look at GN vertex arrays. GLU win. We're truncating. That's interesting. Yeah, that is quite surprising. So that means that name end. Oh, it's name end. It should be +1. This should be like last name char or something. Right? So it's like name end is last name char +1 because it has to be 1 passed. All right. That's not bad. So now we just have to fix this like const void shit. So if we probably need to like trim this shit as well, right? Name trim type name start name end withstood ASCII white space, and then we use name here. Is that where that extra space will come from? Sick. And then const zig name is if name is equal to void, we are any opaque, else name. I'm gonna use zig name here. That's not crazy. That's not that crazy. We probably want to convert pointers to C pointers, right? So this should be like this. But that looks like some valid Zig code to me. Maybe. Not impossibly invalid. I mean, I guess we could run it, right? So we need to run translate C on the actual gl.h, right? So nvim actual gl.h is include gl.h and glx.h, but we don't define the prototypes anymore, right? So we say zig translate C actual gl.h and dash m grep gl mesa. Why is this not working? Oh, is it my bad. Actual gl. This should be gl like this. What the fuck? ls. Where is my like Mesa dev shit? Here. Oh my god. No. GL. Is it here in lib? Oh. We could do this. Package config. Packet? Really? Oh my god. Package config. What is it? Package config? Is it with a dash? Yeah. C flags. libgl. libgl. gl. Package config. I hate my life. M grep gl. M grep. GL VND. Maybe it's in here. I guess I could just have done. I guess I have a bunch of C flags in the environment, and I could have just used those. There we go. Okay. So this is GL translated. Okay, and so now we should be able to run our shit, right? And append this to GL translated. Right? And so now we have all of our shit in here. Okay. So what is he pissed about then? Zig duplicate struck. Oh, I do double up on this shit, huh? That's interesting. What the fuck? How did I manage to do that? Am I stupid? For desire protos, I do this. What the fuck? Wait, I don't understand how that's possible. Translate C. Then we run zig build and am I high? Oh, there's just in here twice. I see. Okay. So now we have to dodge reserved names as well. And then we probably have to type return on all these, right? In Zig, I think it's valid to write return. In this context. Not that bad. Not that bad. So this, I mean, he's not angry. So what I would love to do here is just take this thing and move it into stud and see if it compiles. Right, so if we go here, and this like gl.h for a second, we just like fuck that shit. And we just say, const gl translated is b add module, or b create module. Root source file is gl, is like b path source gl translated that we just manually created. And here we say, yo, use that shit instead. How fucking broken is that, is the question. So if we come back up here and we try to zig build this motherfucker, he's mad because gl create shader doesn't exist. Okay, that's great though. Right, because now it just means that we just have to set up these prototypes correctly. So I would love to quickly also regen sh for now. Translate C. So this is the hard part. Regen.sh. So we have, oops. We have this fucking translate C, and then we have zig build and zig out bin gl loader into gl translated. And then we have a copy of gl translated to Swayland client stud source render source gl translated. Okay. Okay. Oopsies. Okay. So now we should be able to be like GL create, like, what does he want? Shader, right? Okay. Oh, we forgot to fix the types. So we need to dodge in names on the types here. We need to do dodge keyword. In, out. You are the best Hispanic streamer on Twitch. Thanks for furthering representation of the Latino community. I'm not a single piece Hispanic. Just so you know. But you're welcome. Sorry. It's just kind of funny. If in is type return tip return in. All right. Regen. All right. Tip unused function parameter. So we have to dodge the keywords on usage as well. So dodge keyword here. Regen, run that motherfucker. All right, and now he's mad about GL create shader not being work. Pub, wait, we're so close, man. We are so close. The function just needs a fucking pub in front of it. Regen. Okay. We weren't that close. Cannot call optional type this, so when we call the optional type, I think we just throw a little dot question mark on it. Crash our shit. Did I put the return in the generator function as well? No, I did not. But you are right. We probably should do that. GL shader source. We're fucking moving now. Can we do something that's like regen pushd Swayland client popd zig build? There we go. Whoa. Translate type unreachable. So there's a double pointer in create shader. Fuck. Okay, yeah, so probably OpenGL registry XML GL XML. It's like create shaders. Wait, what function was it? What did I just added? GL shader source. So we got a double pointer coming in here. Makes sense. So I guess we just have to fix that. We just have to fix it. While true, probably, right? There's something. I don't know. We find, you know, like var start is 0. We look for this thing starting from, you know, from start, yep. Then everywhere we are working from start to pointer index, probably, right? I guess the type can only be in the first segment. So I think it's probably more like it's more like this, right? You keep parsing for more stars. I guess in reality, we can just do this. Double pointer index is this. Or else, I guess it's just this. If double pointer index, we search for constant before, we check if there's a const in there, probably. So we go from like, index of scalar in the range of, pointer index to this or something. We're looking for const. We say like double pointer const is false. We're really hacking here. I don't give a fuck. If this is not equal to null, double pointer const is true or something. Something like that. I don't really give a shit, man. I don't give a fuck. Then I guess we do our search again. If stood mem index of scalar pause u8 type pointer index double index plus 1. If we find a star, then we don't handle triple pointers. No triple pointers, please. Smile. If double pointer index, we throw one of these in here. And double pointer const label is like if double pointer const this double pointer const label. That should be good enough, right? Right? Whenever I write code like this, I end up regretting it, but I do it anyways. Yep. Yep. I mean, to be fair, I do intend on coming back and fixing it, but, you know. I think this is no Zig name this time. Does this work? Regen. Close. What the fuck? So I have const, then there's just an extra one? Why is there just an extra one? If double pointer const, then I have the const here. It means that Zig name must be name. It must have the const in there for some reason. All right. Yeah. Yeah, we fucked up. Because what function is this? GL shader source. I'm actually kind of confused. GL shader source So he should find const glchar star const star, right? So there's no white space after the double pointer, but that should be okay. Unless I've done something like brain dead, which I probably have. It's that name is from 0 here to name end. Name start is search. Is it that when I constructed the type, I didn't put some spaces when I was supposed to? That's like kind of possible. Didn't I have a debug print in here? What the fuck? So this is like, no, there's a space here. There's no space here, but there is a space here. So this thing should be surrounded by white space. As far as I understand it. As far as I understand it, if name, contains const somewhere, can we like take a little peek at this? Does this return bool? Yeah, it does. Can we just like, oopsies, didn't even do that. Let's do a debug print. Can we just print out like the whole thing that we got in? Something's wrong. Oh, there's so much wrong here, no? Oh, no, sorry. So it's here, yeah, it's this, right? It's that we've stripped spaces somehow. So we shouldn't be, when we append to the type here, if last lm, item, what the fuck is this? Tip items len is greater than 0. We throw a space in here. Right? I think that's the answer. Something like this. There we go. So now this is closer. Funny thing is, const is kind of vestigial. Yeah, I mean, I think it is relevant though. Like, I kind of want it to be correct. You know? GL compile shader. GL get shader IV. Fucking JSON. GL get shader info log. Okay. GL delete shader. I think we're getting somewhere, dude. Great program. Wow. I regret this. This is actually way larger surface area than I originally thought. What kind of OpenGL version doesn't load shader compilation functions by default? Well, shaders are actually new. Original OpenGL, had fixed pipelines. You know, shaders are like fancy because like original GPUs didn't have like arbitrary programmable pipelines, right? They were they had like fixed function pipelines, and then you just went crazy with it. That was like 2 decades ago, though. Yeah. If only there was some pre-warning about this being fundamentally fucked. Yeah, if only. C pointers cannot point to opaque types. What the fuck are you talking about? What the fuck are you fucking talking? What the fuck are we fucking talking about? What do you mean? What do you mean? What else could it point to? Does this mean that if it's an any opaque, we have to use Zig pointer style? That's sick. Is equal to if stud mem equal zig name any opaque. If this is any opaque, then it is this. Else C pointer. Is it like this? What does translate C do for Zoidsar? Who fucking knows, man? But you're right, we should check, huh? Yeah, they do this. They do that. So we're kind of right. GL delete buffers. GL get attrib location. Nice. We're getting more than one at a time now. Look at us go. Huh. If only we could generate for all functions instead of just the ones we cared about. If only. But I bet you that, like, that's more likely to fall over than this. It would have been easier to load every function. You say that now, and I kind of agree, but also I kind of don't agree. Because, like, the chances of us supporting everything that everyone does is very slim right now. Maybe eventually, yes. But I don't trust it yet. I'm okay with doing it like this for now. Yeah, fine. Fine. You're right. We could just fucking, instead of like waiting for the compiler to get mad at us, you're right. We could just fucking type grep. Like we aren't fucking idiots. Grep. What's dash O? What is dash O? Only matching? Oh, nice. That's kind of hype. GL white space plus dash R dot. Can we strip? Let's do A to Z maybe? That's a little better. But we also don't want to do these if they aren't extension functions, right? But I guess we'll see the duplicates easier. Maybe like the duplicates are easier. And then, oops, can we man grep file name H. Oopsies. And then we'll actually throw a to Z capital on there first. And fine. Actually, I don't know, man. We'll see how far we end up having to go here. It might not be that bad. It might not be that bad because I find it hard to believe that we need to like manually load everything, you know? That just seems surprising to me. I could be wrong, but the manual way does feel a little better. Whoa. What the fuck? Get uniform eye proc? Not there. What is it then? Whoa. Get uniform eye. So we take in. Also, surely this shouldn't return void, right? Did I spell something wrong? Oh, maybe get uniform eye was the wrong thing? That's probably what it was. Is that I just fucked up I just typoed. Makes more sense. Oh, it's one eye. One eye. Get uniform one eye. This is a good use of my time, and I stand by it. Get uniform FV. Whoa. Does not. GL get uniform one eye proc. I wonder if GL get uniform one eye is not doesn't follow the naming scheme. Get uniform one eye. PFN GL get uniform. I guess it's like location proc, right? Probably. Right, so GL get uniform. What the fuck is that? Like, does this even exist? Oh, it's not get uniform one. Oh, I'm an idiot. I'm an idiot. I'm an idiot. We'll get there. We're so close. Surely. Surely. Is this a good use of your Saturday? Oh, there's one with a 2 in it. Probably one with a 3 and a 4 in it as well. 10 out of 10. Let's go. Yep, I actually do call the 4-1. Shocker. 1 UI. Surely we're almost there. Surely. It's crazy that all of these are not part of core OpenGL. I was not expecting this, to be honest. Let's go! We fucking compile, baby! Let's fucking go! Okay. So now, does it work? So I think... How do we test this? I think that we apply these changes to a different project. Where are we, like, using... Ah, fuck it. We just, like... I guess we just fucking run it. Oh, we can't really do... I guess we do our cross compilation and go to the VM and test our window manager there is like the only place where this is like easily testable right now. Okay, so here he's mad at GL create shader being like, I can't use null values because we have to load now. That's like a new thing that we have to do, right? So in Friender, we have to expose like pub function init GL, which takes in a loader. which takes in, you know, this and returns any opaque or something, right? And then we call GL load with loader. Probably something like this. And then in swim. Hello? Where the fuck am I? I don't know why that was fucking up, but now we call like stud render init GL. I'm sorry, where the fuck did my function go? Was I on the other stud? Yeah, it was. That's funny. That's funny. Oopies. I have 2 of these. Oopies. That's what I get for foregrounding. I forgot to call comc on there. Expected this, found that, so... whoa. That's a crazy function signature, but I guess, sure. Let's get over here, fix our GL main zig here. So where we thought that returned an any opaque, that loader, this thing returns one of these. Is it this? I think it's this. I don't know, man. We'll see. Expected type const function this, found const function call const found, is it not this? Kill me. It's this. Whatever the fuck that is. Expected type. Oh, I forgot to propagate this up one, probably. What in the fuck am I looking at? I'm just gonna write any type here. Nah, I gotta fucking slap that shit where it's supposed to go. Alright. Error union is ignored. Load is not marked pub. Okay, so we first fix that. Pub function here. Then try here. And then when we call the loader, now we have to pointer cast as well. Something like that. Okay, okay. So now I just try here. Oopsies. Zig build. Ooh, cross compile and run it, baby. Let's see. Means that watching this instead of sleeping at 1 a.m. is crazy. Whoa! Oh! Oh! Let's fucking go, baby! Let's fucking go! It works! It works! Holy shit, that's crazy. That's insane. That's actually, like, kinda shocking. Let's fucking go, baby. Let's fucking go! All right. So that was I thought I was gonna spend like an hour on that. But it was kind of more like 3 hours and 45 minutes. But it works. So all we have to do is like tidy that up a fuck ton, and it shouldn't be that hard to like completely replace Glad. We're kind of like mixing Glad now a little bit. We have to integrate with like our actual thing as well, and find some way. So once we have this like injected into like our standard library thing, we need to find some way to inject extra prototypes to this thing, right? So this is the list of function prototypes that the standard library uses. But we, as like external users of this thing, might add extra, right? So like we have that like, to does function, right? That we want to pull in. But that's easy. Probably. This is a disaster. Absolute fucking shit show. But it's only like 400 lines of shit show, which isn't that bad. It's not that bad. Yeah, cool. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It is 4:30 now. We are supposed to be working on that window manager. Today was supposed to be a mega cleanup day. Tomorrow will be the mega cleanup day because, this took fucking forever. I think this is like good enough, Good, happy with that. But yeah, if you want to see more of us working on like the window manager and stuff, swing back by. 400 lines of parser, that XML. Well, to be fair, I'm ignoring the fact that we copy pasted the XML parser from something that we had before, which is another 700 lines. So a little bit of cheating for sure. But not, not that much. That Lexer is something that we wrote. It's like our dependency that we wrote, so it's not cheating that much. But yeah, so we're working on the window manager every day, 12:30 to 4-ish. YouTube in the Twitch description for most things. This probably will go up there, actually. I didn't think that today's stuff was going to go up, but this ended up being kind of fun, so this will be on there. Some stuff does not go up, though. It really depends on, if I think that it's something that I can create a title and thumbnail for, and if it's like, if I'm putting too much stuff up there, right? Putting 4 hours of stuff a day is too much, but 2 hours is like the sweet spot, so sometimes we hit like a double stream where the first half will work on something small. If you want access to the VODs of that, those are behind paywalls on Patreon, Twitch, and YouTube. If you pay in the appropriate place, you can see the whole VOD, or otherwise you get the part that is like feature development, right? Otherwise, I think that's all we got to plug. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.